Okay, we just did some of this multiplying. So what we're going to learn throughout this whole unit is simplifying, so expressing polynomial expressions in simplified form, and then also factoring. They're the opposite operation because obviously if we simplify, we're multiplying out, and if we're factoring, we're dividing. Okay, so taking a look up at the front, factored form is when it's written as a product. Oops, use this. Oh, I thought I just did that. Okay, product of two or more terms. Okay, so a product means multiplying. That's another word that you have to know. Okay, so everyone's doing this, please. Simplified form is when all the brackets have been expanded. And all like terms have been collected. We also like to list the terms in descending order of degree. Okay, and we practiced that a few minutes ago. All right, so question, or the next part here, simplify these. Well, we just did that, basically. We just did very similar questions. Okay, so let's might as well just practice this quickly. So you do these three questions. You're going to expand out. Maybe you'll have like terms, maybe you won't, but you do those right now. Okay, so that's called the distributive property, where you distribute the monomial out front with every term in the brackets. Okay, so there it is. So let's take a look at just how it works with numbers, right? We're kind of testing it out. So order of operations, if you're back in grade, in middle school or whatever, when you learned order of operations, you would do the brackets first. So that's 6, and then you would multiply by 3, so that's 18. If we use the distributive property, then we would multiply 3 times 2 and 3 times 4. So that's 6 plus 12. What do you get for that? 18. They're exactly the same. So it doesn't matter if it's variables or numbers, you do the same property. You expand it out. If it's all numbers, just use the order of operations. It's faster. So now, what do we do if we have 2 terms in each? So a binomial times a binomial. We have to use the distributive property, but what gets multiplied by what? So let's think about if x is 3, what's the easiest way to evaluate this without a calculator? So think about what that would be. We would put 3 in for x, and that's what it would look like. So order of operations says that we would have then 8 times 5, which is 40. That's pretty fast to figure that out. Okay. Now, is there a way that we could evaluate this without simplifying inside the brackets first? Let's see. What about if we kind of did what we did in the box above, distribute? So let's say I took the 3 in here and I distributed it in the brackets. So I went 3 times 3 plus 3 times 2. Then I need to do something with the 5. Let's see what I get here. 9 plus 6. Okay. Well, then what if I distribute the 5 with everything? So plus 5 times 3 plus 5 times 2. Well, that's 15 and 10. What does 9 plus 6 plus 15 plus 10 add up to? 40. Ooh, it's math magic. Okay, so it's the same thing. This is the long way if it's all numbers, but if it's 2 binomials with variables, it's the only way. Okay, So you have to distribute every term in the first binomial with every term in the second. So if it's a binomial times a binomial, you'll have 4 terms. Usually you'll be able to collect some of those like terms. So here, x times x is x squared. X times 2 is 2x. I like to put the number in front, not x2. Then 5 times x is 5x. And 5 times 2 is 10. So they're all adding in this case because there is no subtracting in the brackets. Then you collect like terms. Those are like terms. So that's going to be x squared plus 7x plus 10. Okay? That's how you multiply 2 binomials together. Okay? So that is basically sort of your new lesson today, although some of you may have done it before, but that's part of 10C. How can we check? Let's substitute 3 in. We know if we put it in above, we got 40. Let's just see if we get 40 in this case. So 3 squared plus 7 times 3 plus 10. So order of operations, 9 plus 21 is 30 plus 10 is 40. Okay, so our conclusion is that x plus 5 times x plus 2 is x squared plus 7x plus 10. First terms together, last terms together, and then there's a middle term. Could be 2 middle terms depending on how many variables are used. So I want you to do the next one just the same. Do 1A. Expand it out. Everything in the first bracket by everything in the second bracket. Then, in this case, 2 like terms. So if you have 2 binomials multiplied together with just 1 variable in it, usually, or almost always, you will end up with just 3 terms because there'll be some like terms when you expand out. So those had x's. Here, that's going to be 2c squared minus c. Do you want to go get a drink of water? Do you want to get a drink of water? Plus 8c minus 4. So negative c plus 8c is 7c. So it'll be plus 7c. Notice how if the terms are in descending order within the brackets, if you expand out following the arrows to the right, then your answer will be in descending order of degree as well. You don't even have to think about it. Now, you may have heard of an acronym FOIL. So the word foil, like tin foil or aluminum foil that you use in baking or cooking. That's an acronym that sometimes students or teachers use. Guys, can you focus on this, please? So used to remember. So F stands for the first terms multiplied together. O stands for the outside terms in the brackets. I stands for the inside terms in the brackets. And L stands for the last terms in the brackets. Okay, so if you struggle with this multiplication of two binomials, this would be some way that might help you. It's not really like, it's not a math theorem or anything, it's just a way of remembering. So here, the first terms in each bracket would be 12r squared. Outside terms in the brackets would be 20r positive, so plus 20r. Inside terms, ones closest together in each bracket would be minus 27r. And the last terms in each bracket would be minus 45. I'm kind of running out of space. So then, collecting like terms, 12r squared, 20r minus 27r, those are the like terms, negative 7r, so subtract, minus 45. Okay, turn over to the next page. We'll do D, E, and F, and then we'll leave it for today. You'll finish the practice of the first part, etc. Oh, what did I just do? There it is. Okay, still a binomial again. What I want you to notice on D is your final answer. What's kind of different about it compared to the other ones we've done so far? Think about what squaring a binomial means or looks like. And this one is a binomial times a trinomial. Okay, so I want you to try those out right now. Okay, so the next one, it's a binomial squared. Listening, please. If you put this as your answer, you are wrong. If you put this as your answer, you are wrong. Okay? It is not conjugates. You will get a difference of perfect squares if they are conjugates. This is not. This is two factors that are exactly the same. So what happens? Let's see here. If we show this the long way, it's the same as 2x minus 3 times 2x minus 3. So now you expand out. 2x times 2x is 4x squared. 2x times negative 3 is minus 6x. Another minus 6x. And then plus 9. So those like terms ends up being minus 12x. So you get 3 terms when you square a binomial. Always. You only get 2 terms if it's a difference of squares. So just do the 2 brackets if you need to. What you could notice, once you get good at this, is this final answer is really the first term squared, 4x squared, the last term squared, 9, and the product of the 2 terms doubled. Negative 6x doubled is negative 12x. So if you wanted to save a step, if you can notice that, and certainly by the time you get to math 20, if you're taking 20-1, we will expect you to be able to go right from that to this. No work shown. Okay. Then last is a binomial times a trinomial. Okay. How many terms do you think you get when you expand out those arrows? 4 we got from 2 binomials, 6 from this one. 2 from the first bracket, 3 from the next. 2 times 3 is 6. Because if you take a look, if I do my arrows, that's 3 arrows there. And then for the negative 3, I'll have 3 arrows. So I'm going to have 6 terms that you have to then collect. So in this case, that'll be 2x cubed minus 10x squared plus 18x minus 3x squared plus 15x minus 27. I ran out of space, so I just put it underneath. Now there's a few like terms. So there's x squared terms and there's x terms. So no other like terms with x cubed, so I write out the 2x cubed. Then negative 10x squared minus 3x squared is negative 13x squared. 18x plus 15x is 33x minus 27. So you end up, in this case, getting 4 terms. It really depends. Maybe I might have x's and y's and z's in that bracket, and then I won't have any like terms. Okay, so that's where we're going to leave it. We'll start at number 2 tomorrow.